Hello everyone, welcome to LX518. So today I am going to share the topic about this 8210 op-amp component from Analog Devices, in which we have built a tester in order for us to see if this component is still safe to be used as good spare. From this video, you might learn how we build the tester, the steps, and how we select the circuit for the application, and the benefits, how important the tester could be moving ahead in our repair service. Alright, so stay tuned, the details are coming up right now. Okay, so to give you the background, we actually found 22 units of unknown condition of this 8210 Analog Devices op-amp. We found it somewhere inside the storage room. So as stated here in this slide, without identifying the condition, people may be scared or refrain to use this component in their repair unit, and ultimately it will lead to abandonment and most likely will be going to scrap eventually. Imagine the price of this unit per piece is around 162. So the total cost for 22 component will be around 3.5k USD. How the company will think by scrapping this unit blindly. Alright, so as you can see from the images, you can see the actual photo of 22 quantity of 8210 op-amp. This op-amp has been used mostly in one of our power supply, actually in one of our power supply controller, in which is installed in the equipment for the implant process. Alright, so let's move to the next page. Thank you. So for the action taken in order to save the component from scrapping, we actually build a tester or a checker to identify if this 8210 that we found from storage room is still usable or functionally working fine. So the first step that we did is to download the datasheet of this 8210 component, and we look for a sample application circuit. Then once we select the easiest application circuit, then our team build and actualize the circuit and assemble it into a hardware and try to test the 8210 component. As you can see from the image, on step 3, the testers that we build are working well. Thank you. And in this page, we have tested all the 22 components, the 22 unknown units, and as you can see from the table and the measurements, we have identified or we have defined the criteria to conclude if the 8210 is faulty or not. Thank you. And then on this page, I'm showing you that we made the tester more presentable by building it into a casing. It looks better now and ready to use and to share to the team. And finally, for the benefits, we have actually saved 16 units avoided from potential scrapping. And the total cost of these 16 units is around 2.5k USD. Imagine if we didn't build the tester, we end up scrapping all these 22 components. And for the lesson learned, of course, you can always build your tester, especially for expensive spare part. You can always download the datasheet and look for the application circuit, assemble it up, build it up, and then use it to test your component. Continue on helping the company to save money, and you learn new things as well. Thank you. To summarize the steps, of course, the first one is to select the parts that you want to build the tester. And then you identify that part by checking the part number or any markings on the part to download the datasheet on the step 2 and understand the part a little bit, and then you must select the application circuit that you think is easy for you to build. If you cannot find the application circuit on the datasheet, you can try also to Google it, and I believe you can find some application in Google that you can use for testing your selected part. And finally, on the step 3, you have to build the application circuit into hardware and test your part. You must develop the pass and fail criteria based from the details from the application circuit. Alright, so that would be the 3 steps that I summarized for you to start on building your tester for your electronic component. Thank you. Alright, that's all for this topic. Hoping the video is helpful for some of you. Wish that I could do better next time. Thanks for watching and keep safe. Let's go!